We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
I feel the liftoff. The clock has started.
Okay, I'm separating from the spacecraft. Getting my feet out. Okay, I'm out. Really looks funny out there. See my glove out there, Jim.
Jimmy 4, good back yet. Good morning, Gordo.
Yes, I am.
How did it feel for the United States to be the new record holder?
At last, huh?
Liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 51 of the Space Rocket History Podcast. And now, Gemini 1, Test Flight. The primary objective for the first Gemini mission was to prove that the Titan II was capable of launching the Gemini spacecraft into orbit within the tolerances imposed by manned space flight. The secondary objective was for the spacecraft to gather and report data. Spacecraft 1 was therefore unique among the products of the Gemini assembly line in St. Louis in being largely without standard spacecraft systems. For the most part, it carried dummy equipment and ballast to match normal weight, center of gravity, and moment of inertia. Spacecraft 1 had one structural difference from later models. Since mission plans did not call for the spacecraft to be recovered, the heat shield simply completed the structure, and 4 large holes bored in the ablative material ensured the total destruction of the spacecraft when it plunged back into the atmosphere. Working equipment was mounted on 2 special pallets located where the crew would be in later flights. Spacecraft 1 carried 2 active Gemini systems, a C-band radar transponder and related gear to help ground radar keep track of the spacecraft, and 3 telemetry transmitters to return data to Earth. Data was to be gathered by a set of special instruments that measured pressure, vibration, acceleration, temperature, and structural loads. McDonnell began testing Spacecraft 1 on July 5, 1963, with plans to have it at Cape Canaveral by mid-August. The first phase of the spacecraft system test centered on making sure that each working piece of equipment functioned properly. Unfortunately, much of the equipment did not function properly and thus brought testing to a halt on July 21st. The instrumentation pallets had several defects, especially in their electrical circuits and in their response to vibration. Other problems included a transmitter and a radar beacon that had to be returned to their makers to correct out of specification performance. With these matters taken care of, testing resumed on August 5th and proceeded smoothly to the end of the first phase on August 21st. 4 days later, McDonnell workmen mounted the major spacecraft modules. The now fully assembled vehicle was ready for the second phase of systems test, checking its overall workings and the compatibility between the mated sections. It was now slated to arrive at the Cape on September 20th. During the first half of the month, tests altered with leftover manufacturing tasks, which slowed things down, but not too seriously. All systems performed well during the last half of the month as the spacecraft was vibrated to simulate launch, then transferred to the altitude chamber for simulated flight test under orbital conditions. The testing concluded with a complete integrated systems test on September 30th. A good share of the program office and a sampling of the rest of NASA were on hand the next day to watch Spacecraft 1 as it rolled out of the test area in the McDonnell plant. Throughout the morning, McDonnell experts lectured their NASA guests on the spacecraft, the status of each of its parts, and the results of testing. After lunch, the NASA party retired behind closed doors to ponder the fate of the spacecraft. The McDonnell staff gathered late in the afternoon to hear the decision. Spacecraft 1 had been accepted for shipment to the Cape. The spacecraft arrived at Cape Canaveral on October 4th for the next round of testing. The Gemini Project Office had decided early in the program that Gemini pre-flight checkout would conform to the Mercury pattern, even though the two-man spacecraft had been designed to render that kind of repeated testing unnecessary. Plans called for the spacecraft to be broken down to its major modules, each of which was retested to the subsystem level. After being put back together again and passing a series of integrated tests culminating in a simulated flight, the spacecraft was to be transferred from the industrial area to the launch complex. Since Spacecraft 1 lacked most of Gemini's normal systems, it was much easier to check out than the later Gemini models. By the evening of February 12, 1964, the task was finished. The next step was a formal pre-flight readiness review of the spacecraft's status, both physical and functional. Gemini manager Charles Matthews and a team of engineers from Houston and Cape Canaveral conducted the review on February 18th and 19th. They found nothing that would prevent the spacecraft from being moved to the launch complex, nor that seemed likely to delay the launch. Unfortunately, the Titan II launch vehicle was not ready for mating, so Spacecraft 1 waited until March 3rd before it was transferred to Complex 19. While the spacecraft waited, minor work continued, especially on the spacecraft shingles. These beryllium shingles were part of the heat protection structure and covered the external surfaces of the two forward modules, the rendezvous and recovery canister, and the re-entry control system. A fully acceptable fit was not, in fact, achieved until after the spacecraft had been mated to the launch vehicle. Building and testing the first Gemini launch vehicle, which is abbreviated GLV, was not as easy as getting the spacecraft ready, because GLV-1 was not a stripped-down version of the launch vehicle. Instead, it had to perform the same functions as all the latter boosters in the program. Just as McDonnell has been building the spacecraft despite hard-to-resolve problems in some spacecraft systems, the Baltimore division of Martin Marietta had been building launch vehicles for Gemini, even during the long months when the Air Force and its contractors were struggling to make Titan II reliable. Titan II was built around its propellant tanks, one for fuel and one for oxidizer, in both the first and second stages. Martin's Denver division, which held the missile contract, also provided the tanks for the Gemini boosters. The set for GLV-1 was shipped to Baltimore in October of 1962 after a lengthy series of tests, with special attention to welded joints to be sure they were both strong enough and leak-proof. The tanks were ready for formal inspection in mid-February 1963. Only 3 passed. The second stage oxidizer tank was cracked. It was returned to Denver and replaced by the tank intended for GLV-2, which reached Baltimore on March 1, 1963. By May 21st, the first Gemini launch vehicle was fully assembled and ready to begin testing as a unit. A check for wiring continuity revealed a short circuit in the second stage where a wire's insulation had been cut through by a defective clamp. When inspectors found several other clamps with the same defect, every one of the more than 1,500 wiring harness clamps in GLV-1 was removed, all wiring inspected, and a new set of clamps installed. When electrical continuity had been confirmed, the first stage was erected in Martin's new vertical test facility on June 2nd. This facility was a tower 56 meters high, adjoined to a 3-story blockhouse fitted with test and checkout equipment similar to Complex 19 in Florida, that would later launch GLV-1. The tower and blockhouse inside the Martin plant were designed to provide test data and to be compared with data gathered during checkout at the Cape. The first phase of the test planned subsystem function verification to make sure that each of the vehicle's subsystems were working. It began on June 16th. These tests went more slowly than planned. For one thing, the second stage had been late going up, partly because of electrical problems and partly because its engine arrived late. For another reason, minor troubles cropped up, such as hydraulic tubing that was not fully cleaned, solder flux that had been boiled from a pinhole in a joint and gummed up a gyroscope. By the end of June, subsystem testing had fallen about 2 weeks behind schedule. It was a source of concern, but as yet no threat to the launch planned on December 1963. The functional verification test lasted until late July, when a review of the data by the Air Force Space Systems Division, abbreviated SSD, and the Aerospace Corporation found GLV-1 ready for the next phase of testing. GLV began combined tests on July 31st with a series of tests designed to uncover any interference between the vehicle's several electrical and electronic systems. 5 systems failed to meet standard after the first round of testing. Efforts to correct the problems, mainly by adding filters and grounds to age and airborne circuits, produced results, though slowly. Only after the 6th test on September 5th was all interference cleared up. The launch vehicle's last hurdle was a combined systems test, which included a complete launch countdown, simulated engine start, liftoff, and flight, and ended with the simulated injection of the spacecraft into orbit. After several practice runs in conjunction with the electrical-electronic interference testing, Martin conducted the formal combined systems acceptance test on September 6th, then presented both the data and the vehicle to the Air Force for acceptance testing on September 11th. For the next week and a half, the vehicle acceptance team, headed by Space Systems Division Colonel Richard Deneen, met at the Martin plant in Baltimore. SSD, NASA, and aerospace inspectors explored the vehicle and studied its manufacturing and test records. This detailed inspection disclosed severe contamination of electrical connectors throughout, as well as a broken idler gear in the turbo pump. These defects, plus the fact that 42 major components had yet to achieve documented flight status, forced the team to reject GLV-1. Failing to pass this type of inspection on the first try was not unusual, but it meant another long delay for GLV-1 to reach the launch site. No sooner was the inspection over than Martin technicians began to set things right. Armed with magnifying glasses, they searched every one of the 350 connectors aboard GLV-1 for traces of contamination and found 180 needing to be cleaned or replaced. All flight control equipment that had produced transient malfunctions during combined systems acceptance tests was removed and analyzed. Defective units were replaced and wiring harnesses reinstalled. At the same time, Martin tried to complete documentation of failure analysis and qualifications of flight hardware. This extensive reworking of GLV-1 invalidated most of the earlier test results. Martin's plan for an informal retest of problem areas only was rejected in favor of a full-scale repetition of the combined systems acceptance test. Subsystem testing and preliminary acceptance tests were finished by October 2nd. The second formal acceptance test of GLV-1 ran on October 4th. This test uncovered very little that needed to be corrected. Deneen's team reconvened at Baltimore on October 9th and took only 2 days to complete its work and decide that GLV-1 could be shipped to the Cape. The team was scarcely enthusiastic about the vehicle. Much work remained to be done on GLV-1, but it could be done at the Cape, and there at least GLV-1 could be helping to check out the launch complex itself. On October 26, 1963, GLV-1's 2 stages were strapped to an 8-wheeled trailer, were towed to the Martin Airport next to the plant, and rolled through the rear loading door of a huge C-133B cargo aircraft provided by the Military Air Transport Service. A 4-hour flight brought the 2 stages to Florida. Still on their trailers, they were rolled from the aircraft into the hands of Joseph M. Verlander's Martin Canaveral crew, who towed them to Hangar H to be unpacked, inspected, and fitted with the gear required to erect them. There they remained under guard over the weekend. On Monday, October 28th, the trailer bearing the first stage reached Complex 19. At the launch complex, the Martin crew trundled the first stage up the long ramp to the launch vehicle erector, which rested on its side parallel to the deck of the test stand. The trailer rolled through the large door and stopped 1.5 meters from the other end. The crew secured the stage, removed the trailer, and closed the roof door. A 150 horsepower electric motor then winched the 140-ton erector upright, a process that took several hours. The trailer-borne second stage arrived at the launch pad a day later. Ordinarily, the next step was mounting the second stage on the first, but GLV-1 was slated for a special static firing test in mid-December, and the sequenced compatibility firing of both stages. So Stage 2 was placed in the second stage erector, a small structure used only for checkout or static firings, and the 2 stages were cabled together after checking to be sure there was no interference. Verlander's team applied electrical power to the 2 stages, standing side by side on November 13th. Work at the Cape on GLV-1 was already a week behind schedule. Problems in Baltimore had pushed the launch date from December 63 to February 64. Another 2-month delay now threatened. Charles Matthews said he was, quote, greatly concerned with the present situation regarding the Gemini program at the Atlantic Missile Range, end quote. There were 4 different groups: the SSD, the Air Force Aerospace Test Wing, Martin Baltimore, and Martin Canaveral, testing and checking out the launch vehicle, with no formal understanding on how responsibilities were to be divided among them. Clarification was not long in coming, but meanwhile matters had become so confused that 2 distinct launch test directives had surfaced. To make matters worse, NASA people at the Cape complained about a lack of access to technical data from the contractors. Poorly meshed working groups compounded other problems. A time-consuming review of the official work plan, procurement snags, and most serious, questions of compatibility between the booster and the aerospace ground equipment, which extended the planned number of working days to get GLV-1 ready for launch from 86 to 118 days. By November 22nd of 63, Matthews had to tell Siemens that even the already late February 28, 1964 launch date was likely to drop back to April 1st. In a move to help resolve management problems, Matthews united the coordination panels that were dealing with Titan II and related areas into a single Gemini Launch Vehicle Coordination Committee with 6 standing panels. All panels were to meet at the same time every 3rd week, then report to the parent committee, which would decide what action was to be taken. This was intended to eliminate delays caused by uncertain authority, duplicated effort, or conflicting decisions. Matthews and GPO launch vehicle manager Willis Mitchell also took steps to make good some of the time already lost. The Martin crew switched from 2 8-hours to 2 12-hour shifts a day. Checkout problems persisted, however, and the scheduled sequence firing slipped from December 20th, 63 to January 3rd, 64. But the problems refused to end. The combined systems test scheduled for December 13th was twice postponed and finally completed on New Year's Eve. Lack of compatibility between the booster and its support systems in Complex 19, as well as a faulty turbopump assembly that had to be returned to Aerojet, were the major causes of the delay. Next was the so-called wet mock simulated flight test, a complete countdown that included filling the propellant tanks. It was voided on January 3rd by procedural errors after propellant had already been loaded. The test was called off 2.5 hours before the simulated launch, although the count went on until T-30 to see if any other problems turned up and to give the operations crew some practice. Another try on January 7th was a success. The countdown for sequenced compatibility firing was now set to begin, but a 3.5-hour delay was imposed by contaminated oxidizer. Then, during the countdown, a malfunctioning first-stage propellant valve caused the test to be called off for 20 minutes before firing. A second try on January 14th had to be canceled because unusually cool weather had chilled the engine start cartridges below the 35-degree Fahrenheit specified as the lower limit by Aerojet. Finally, on January 21st, the third attempt overcame some minor problems and delays to show the whole sequence of fueling, countdown, ignition, and shut-off commands, guidance control, and telemetry. First stage engines fired for 30 seconds and cut off. The second stage ignited and fired for 30 seconds and was halted by radio signal from the ground computer as in the real flight. Sequence compatibility firing proved that the engines delivered the required thrust and gimbaled properly. This static firing, the only one performed on a Gemini launch vehicle, met all the pre-launch standards. With static firing finally out of the way, the ground crew could now begin getting the booster ready for the spacecraft. That meant putting the second stage on top of the first, which was scheduled for January 27th, but post-firing cleanup found a defective rotor in one of the turbopump assemblies. Shipped to the West Coast for repair, it returned to the Cape on January 29th. Then a missing seal held up its reinstallation until February 7th. The launch crew did not wait for the new seal. The turbopump assembly could be put back in the second stage after it was erected. On January 31st, they removed the stage from the small erector and secured it in the launch vehicle erector, which was then winched upright. The upper stage was gently lowered onto the first, and the two were bolted together. GLV-1 had assumed its final form. But before the spacecraft could be mated to the booster, there were still subsystem function verification tests to be conducted. Although these tests were supposed to start on February 14th, lack of spare parts and questions about failure analyses imposed another week's delay. Once testing began on February 21st, however, it went smoothly to verify the launch vehicle's readiness for full system testing by March 3rd. On that day, Spacecraft 1 arrived at the launch complex to be installed in the spacecraft erector support assembly in a controlled access white room atop the launch vehicle erector. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange Donate button or the Patreon link. Thanks.